Hello. I recently made a trailer about estimation and the revelation that you need to estimate everything you do. So let me explain why. Just a note, however, this video will not be debating the use of points or their veracity. I've used them for years, and if used correctly, they have great utility. Points are not the only way to estimate, of course, but what I'm about to show you demonstrates why they're easy to use. Okay, so you've just planned your sprint, and you have your sprint backlog all locked and loaded, you know your average velocity, and you've chosen work that will achieve the goal that you've agreed, and that you think you can complete based on that known velocity and your historical trends, whatever you've used to determine that. Oh, but wait a minute, remember those bugs that need to be resolved, and what about that tech debt we have to spend some time working on? How much of your velocity is that going to eat? Not sure, as we don't estimate that stuff apparently. But what about when an emergency tech support issue arrives, or what are you going to do about that then? And what about all that stuff the manager keeps asking for all the time? Oh, so that velocity isn't really your real velocity after all, and if the various unplanned work varies every sprint, how will you know what number to use at sprint planning? Maybe you're starting to see the importance of estimating everything now. So backlog consists of work to be done, says the Scrum Guide. We call it a product backlog, but that term is misleading, as really we don't just do product work, and if we do, we are very fortunate. It's much more of a team backlog that contains all the work for the team to be done. Now, just to be clear, bugs, tech debt, and support of the product you work on is all product backlog. It's not just the new features, folks. It's anything to do with that product that creates work. And most teams I know work on many products, so while you may have a product backlog for each product, which is what it says, the team ends up getting a bunch of work from a number of different sources. Yep, we're back to the idea of a team backlog. Now, I know this is not how Scrum was designed, but welcome to reality at the end of the rainbow. I'm going to show you a few techniques to help you work in this mad, crazy world. These are techniques that work for me. The first is the importance of making work visible. This is the difference between work as imagined, how people think work gets done, versus work as done, or how work is actually achieved. If you hide all that unestimated work, good luck convincing the boss why your team doesn't really suck, or that you really need additional capacity. When the boss comes asking why you are not getting the planned work done, and you tell him or her, there are just too many interruptions, how do you prove that? What measures of unplanned work are you able to show to support your statement? Well, we have all these other things, boss. Honest, we do. The concept of and-on, meaning lanterns, and an and-on board comes from Toyota, and it's the way all necessary data is displayed so that effective decisions can be made. You should already be using some form of visual radiator of the work you are doing, and if it's in the pits of madness known as Jira, it should be on a big screen so it can be seen by everyone. It's called visualization for a reason. The next technique I'm going to show you is how to manage unplanned work or interruptions to your work. Any planned work should already be in the backlog and estimated. I'll also explain a technique for estimating unplanned work, such as those bugs and defects and that tech debt. It even works for technical spikes, but there's another way you might be able to use to estimate technical spikes. Okay, let's get started and see what you think. Now, I've talked a lot about the importance of making work visible, and in this simple exploded pie diagram you can create an Excel or something similar. You can see how this team has visualized its work. The team has a velocity of around 75 points, but as you can see from this diagram, they've only used 28 points, or around 38% of their velocity, on new stuff, new value, features, functions, capabilities in the product that they're building. There's a little bit of work being done in improvements, the Kaizen items, that's around 10% of their capacity, or 7 points if you prefer. But all the rest of that velocity is being consumed working on technical debt, being interrupted, some essential keep the lights on / run the business type activities,
or indeed some sort of management reporting. In this example, you can see that Team Pixar has only had 51% of their velocity focused on creating new value, new features, new functions, new capabilities. You can see that the rest of their velocity, 49% of it, about half of all their capacity in the sprint, has been consumed by interruptions due to support work, interruptions in this thing we call a buffer, which I'll get to shortly, and about 18% on doing some improvement work within their particular sprint. In this example, from the next sprint, you can see that the team's consumption velocity changed again. Only 48% this time was spent on new value, with the rest of that sprint, 52%, being consumed elsewhere. And in this case, you can see they did some support work, maybe some help desk tickets. They had 17% of their capacity spent on remediating technical debt, and 31% was spent on doing improvements. This is the information that you need to be sharing with leadership and management so they understand where your capacity is being eaten away. If you're working on bugs, technical debt, support work, other interruptions, and you're not making that visible, as far as management's concerned, you're not doing it. So let's start talking about how we might be able to estimate some of this unplanned work, especially support calls that come in and other interruptions from whatever source they're coming from. Imagine you've got a bunch of historical data. You've been doing work for a while. You have some help desk tickets, and this actually is the ideal way for a support desk, a help desk, an operations team to estimate work, to be able to judge their capacity and be able to measure a velocity for their team, even if the work is highly variable. So imagine you've got a bunch of examples of this variable unplanned work that's occurred in the past. The first thing to do is to go and throw up some t-shirt sizes, small, medium, large, etc., and then sort the work into those various categories. So now we have a scale, a reference table of lots of work we've done before, and they're put in similar size categories. You've done the work, so you know how big it is. Now, calculating with shirt sizes or sizes of animals or fruit or something other random object isn't really that useful. So let's go ahead and change those for some numbers, and I'm just using the standard Fibonacci scale here, and I'm starting at 5 because I don't know if something will ever end up being smaller than 5, so I'm giving myself a few numbers to allow us to go a little bit lower than 5 points if need be. Now we have a scale. So now whenever a new piece of work comes in, we can very rapidly compare it to an existing piece of work which we know the size of and determine how big this new piece of work is. So here's the crazy thing. You get a piece of work come in, you have no idea how big it is. So go and do the work first. Once you've completed the work, you can now compare it to your reference scale and say, hey, it was very similar to this support call we did before, 13 points. Now you've estimated it. Nobody said you had to estimate it before you did the work. You can estimate it after you did the work. And this is extremely effective. Now let's talk about those technical spikes where you don't really know how long a piece of string is until you've been and done the research. So there's a couple of ways of doing this. You can use the technique we just talked about, which is go do the research and then use the affinity estimation to size how much was spent on that in terms of capacity. The other common way of sizing spikes is to time box them. But we really don't want to be estimating in time, especially if we're using points, because points and times are like oil and water, they don't mix. However, there is a little trick you can use, but you have to take it with a health warning. Let's assume your team's average velocity is 50 points. Your sprint length is 2 weeks. Let's assume you're going to use 50% of the team's capacity, or 50% of the sprint if you prefer, 5 days in this example, to do research, or a spike. We can then say, proportionately, the spike is equivalent to 25 points of the team's velocity or capacity, which is overall 50 points for the 2 weeks. Now, there is a flaw with this, of course, is it assumes a linear run rate per day, so many points per day, which of course is not true. In practice, this has worked well enough for the number of spikes versus planned and measurable work. The other thing you have to do is every single sprint the velocity will change, or maybe the average velocity fluctuates over time, so the calculation must be done within that sprint, not as a general calculation. As I say, this is one technique. Using the affinity estimation technique where you've done the research first and then you compare it to get an estimate based upon relative sizing or comparative sizing to previous known work is probably slightly more accurate. Again, you should always time box a spike, because otherwise people just go, no, I need more time, I need more time, I need more time, and before you know, the research spike is 4 sprints long. Now let's look at how to manage that unplanned work. We've learned how to estimate it all. We've learned why it's important we need to estimate all the work and make it visible. Now let's understand how to manage that work correctly. Here we have a product backlog with some ordered, prioritized, and even estimated work items that have been estimated and refined during backlog refinement, which is where it should be estimated. The team have planned their sprint, and we can see the team has a velocity of 39 points in this example, but if you're quick with math, you'll see that the team have only pulled 29 points of backlog. They have an improvement story there at the top, a 3-point backlog item, and then some other items to achieve the sprint goal and to deliver some value at the end of the sprint. But what happened to that other 10 points? Where did that go? Well, the team have reserved that as what they call their buffer capacity. 10 points in this example, and again, these are just example numbers. The numbers you would reserve would vary within your context, depending on the average number of interruptions you may experience in a sprint. An important thing about the buffer capacity, this is still real capacity. It hasn't gone away anywhere, it's in reserve. If the team don't consume it through unplanned work, they can just pull from the product backlog within a conversation with the product owner and decide what other items they have the capacity to pull in within that 10 points and complete during the sprint and deliver some additional value. Now, to manage the interruptions, we use the product owner. The product owner becomes the gatekeeper of this capacity. If you've seen the video on large effort estimation, you'll remember I talked about being able to calculate the cost per point. If you have a team that's a reasonably fixed cost per sprint and they have a certain amount of velocity per sprint, it's a simple calculation to calculate the cost of each point. So with that in mind, we don't want people just bumping into the team and disturbing them with any old work and consuming that money. This is real money we're talking about here, not some artificial points, but actually cost for the capacity of that team. So the product owner becomes the gatekeeper. And as requests come in from support, from management, from other sources, maybe another team asking the team to support them or another individual, the product owner acts as triage. The product owner works with these other stakeholders, asking them why they want to interrupt the team and assessing with them the urgency of it. Is it within an SLA agreement? Is it some other urgent matter that needs to be resolved and cannot wait? If the product owner agrees with the stakeholder, we should use some of that reserved capacity. The work is allowed to be passed to the team and to interrupt the team, and we will decrement or decrease the amount of available points in that buffer. Now, we can either estimate the work before we do it, or as I've explained, you can estimate the work after it's been done and then reduce the buffer by that amount of points, and so we know how much we have left in reserve should we need it. The product owner may discuss with the stakeholders that we might want to do it later, and if so, we'll just add it to the normal product backlog and prioritize that to be done in a later sprint. But bear in mind, the more we add to the backlog, the higher the cost of the initiative, or the longer the time it's going to take, or a reduction in scope equivalent to what we're adding to the backlog may need to be made later. There's nothing for free in this game. Finally, the product owner may decide that this is never going to be done by this team, and I'm sorry, but no means no, this work won't be done. The power of this interrupt pattern is the management of the buffer. If the buffer reaches capacity or overflows, we will pull the and-on cord, abort the sprint temporarily, call an emergency sprint planning meeting where we will bring the relevant stakeholders together to discuss what capacity remains to complete the sprint goal, if at all possible, or what changes we're going to have to make as a result of exceeding the team's capacity. Do we make them work overtime? Do we ask them to work at the weekend? Do we de-scope? Do we push work further out in time? These are all questions that have to be answered. Again, there is nothing for free here. If you add in work, some of the work won't get done, or will be done later, or the cost will increase, or we'll have to expand time, or add additional capacity, which is additional cost. So how about support teams, helpdesk teams, operations teams? Well, the pattern's more or less the same. We have a backlog of some planned work. Everybody has some planned work. In this case, the team for their sprint or this period of time, if they're not actually doing sprints, but a period of time, they've decided they're going to do this small improvement story, the Kaizen, and they've got some planned work, which is equivalent to 5 points of capacity. The buffer is just a lot bigger, in this case 90% in this example. The pattern works just the same. There's requests coming in all the time, there's a triage necessary, there's a decision whether to do it now or later. The buffer is the available capacity of that support team for that period of time that's being measured. And if you're using a Kanban technique where you've got an intake queue and you're pulling work from the intake, again, that needs to be prioritized, needs to be sized, needs to be triaged for urgency, service level agreements, and you will be consuming the amount of capacity the team has. If you start to measure your team's capacity in this way, you will be able to have a conversation with management about the capacity of a support team and the fact that they either needs to be increased or modified in some way based upon the real facts and data that you are collecting. You can then draw a simple burndown chart. Most of us use burndown charts. I use them all the time. So on the x-axis we have time, which is our duration, 1 to whatever weeks it happens to be. If you're doing sprints, then it's the duration of your sprint. On the y-axis you've got the number of points. In this example, the team's capacity for this sprint is 50 points. But using the buffer interrupt approach, they've only taken 40 points of work, again in this example, and they've left a reservation of 10 points. They've drawn two lines, one which is the sprint goal, which is the 40 points to achieve the sprint goal, or their estimate is, and then 50 points, which is their current known average velocity. So we have this range, this cone of available capacity or spare capacity. If the teams stay within the 40 points for the planned work, then they have the 10 points spare capacity they can use for interruptions through the buffer interrupt pattern. This can also be used to pull additional work if not consumed through interruptions. As long as we're in between those two lines, the 40 and 50 points, we're good. If we find we're going outside of the 50 points, it's time to pull the and-on cord and suspend or abort the sprint until we have an opportunity to replan. Some examples of how this has been implemented in other companies to encourage the right behaviors. This is 3M. They put a sign on the roof in one particular team, please get with our product owner to add an item to our backlog, now serving customer 22. In Bose Corporation, the Scrum Master Amy used to say, if you're not a sticky, you don't exist. So the team put up a label, if you're not a sticky, you don't exist. Please see the team Pixar product owner if you want to exist. This is one example of how the buffer interrupt may help you in a scaled approach, and in this particular scaling approach, we're using a chief product owner concept. A bug comes in, needs to be attended to, a support call. So we go to talk to the chief product owner who's working in that business area where this support call needs to be handled. The chief product owner can then talk to the product owners of the various teams or working on various products or product backlogs, and they can ask these product owners, hey, has any of your team got any spare capacity in that buffer they've reserved? Yep, this particular team has, and they're cross-skilled and multifunctional across this particular business area, so they can pull in that support call and actually complete it. So there you have it. The importance of estimating all work, the importance of making all work visible, some techniques to help you estimate work that's unplanned, some thoughts on how to estimate spikes or research work, an explanation of how to manage interruptions using the buffer interrupt pattern, some techniques to visualize that buffer to drive the appropriate behaviors in business, and how to use that in a scaled implementation. I hope this was useful to you. Thank you.